Hello! So in this video we're going to try and solve or find a particular solution for a non-homogeneous differential equation. So if you remember, this is exactly the same differential equation on the left-hand side as we had in all of the other previous videos. So we know what the complementary solution is. We worked it out before. It's this thing up here. Okay, and we now seek a particular solution because if we add the particular solution that we find to the complementary solution, then that will give us the general solution to this differential equation. So basically we're looking for a particular solution. It's based on a guess, but it's actually not that bad. So basically the idea is, in all the other previous videos, you just look at this right-hand side, because that right-hand side will give us a pretty good idea, a pretty good indication of what, the solution to try is, of what our y to try is. And what we're going to actually try is, as you see here, the reason which sets this apart from all the other ones. So we've looked at all the other cases. We've looked at the exponential, we've looked at the sine and cosine case, and we've looked at the polynomial case, which, if you remember, those are the three cases where we can use the undetermined coefficient method for. As long as these constants here, these coefficients here are constants, then we can use the method of undetermined coefficients, providing the right-hand side is either exponential, polynomial, or sine and cosine. Okay, and so as you can see here, this right-hand side is a combination of exponential, and of cosine. Okay, so therefore it's a product of the two, and that's absolutely fine. Equally we could have had a polynomial in here as well. Okay, but all we're going to do is we're just going to basically build a solution, a particular solution for the right hand side. Okay, based on what we've already seen before. So if you remember, let's say minus 8e to the t, if it was just minus 8e to the t, then what would we try? We'd try a particular solution for that of, what would you try? Some constant e to the power t. Some constant e to the power t. Okay, if it was just, it's cos 2t. If it was just the cos 2t on the right-hand side, then we try a particular solution of sine 2t, so a combination of sine 2t and cos 2t, and we just have some multiple of the two, so let's just say d and e. Okay, so just some constant coefficients going through. But because now it's minus 8e to the t times cos 2t, then it makes sense that the general solution we'll try is to build it from these two solutions being multiplied together as well. Because, we've got a right-hand side of, the exponential and the cosine being multiplied together. So therefore the general the solution, the particular solution that we're trying to find, will be multiplied. It will be a multiplication of these two. We kind of build it from what we already know. So in other words, it's going to be ce to the t times by this thing. So in other words, we just multiply these two things together. So 2 sine 2t plus e cos 2t. Okay, so just multiply these two things together. Okay, so let's get rid of that just to make a little bit more space. Okay, but now look, if I just multiply this out, because we can actually simplify this down. You could go ahead now and try and find the derivatives of this, but we can actually make it easier for ourselves just by multiplying it out, so we don't end up with loads and loads of constants. Okay, so let's have a look. Well, actually, no. I think actually what I'm going to do is I'm going to differentiate it straight ahead now, because this is actually an easier form to differentiate, and then I'm going to try and make some simplifications so we don't end up with loads and loads of constants that we have to find. Because at the moment we've got 3 constants that we have to find. Okay, but let's just multiply this out. So in other words, we need the first derivative. So the first derivative, these are two functions being multiplied together. Are you happy? It's it's this times this. Okay, so treat them as two functions being multiplied together. So therefore, when we differentiate, we're going to have to use the product rule. Okay, now the product rule is just the derivative of this, ce to the t, multiplied by this left alone. So d sine 2t. Okay, plus e cos 2t, okay, and then plus the derivative of this thing plus this thing left alone, so plus ce to the t, okay, and then what have we got? We've got plus ce to the t, and then we've got the derivative of this thing inside the bracket, so it's going to become, we're going to need a little bit more space, I'm just going to stick this on the bottom, just for the moment, so this is plus that. Okay, so I'm just going to find the derivative of that thing. So it's going to be a cos. It's going to be d cos 2t. Okay, but again, by the chain rule, we also have to multiply by the derivative of what's inside the brackets. So it's going to be 2. Okay, same kind of thing for this thing over here. It's going to become minus e sine 2t. okay? But we're going to have to multiply by the derivative of what's inside the brackets. So it's going to become 2, okay? So now what I can just do is I've got ce to the t there, ce to the t there. I'm just going to take it out the front, okay? And that's then going to become a plus in there. So in other words, I'll just try and simplify these two brackets in here. So I end up with 2. So what do I end up with? I end up with yep, okay. So let's put the causes together. So I end up with, I've got d sine 2t and a minus 2e sine 2t. So are you happy then? I can just rewrite this. I can just rewrite this as, just move it over. I can just rewrite this as d minus 2e sine 2t. Yep, and that I can combine those two things together. And likewise for this one, I can just write it as I've got an e sine 2t, e cos 2t, and a 2d cos 2t. So I can just rewrite this as e plus, so 2d plus e. Yeah, I've just combined the two things together. Okay, so let's write this up here then. Okay, so this is just making the next differentiation a little bit easier, rather than just doing loads and loads of product rules again, over and over again. So let's do the second derivative now. So it's just going to be same thing, derivative of this thing. So it's going to be product rule. So it's c e to the t multiplied by the derivative of all of, c e to the t. So I've differentiated that to get that, multiplied by this thing left alone. So let's just leave that thing alone. Okay, so that's the first term, and then I want that plus this thing left alone, so c e to the t left alone, multiplied by the derivative of this thing, So what do I end up with here? So I end up with, again, similar kind of thing. Derivative of sine goes to cos, so I know it's going to be d minus 2e, which is just constants, times by the derivative of sine, which is going to be cos 2t, but then I'm going to multiply by what's inside the brackets, chain rule. Okay, so that's going to be 2, lots of that. And then I want the derivative of that thing, so that's going to become minus 2d plus e, okay, times by the derivative of cos, which is sine 2t, and then I want the derivative of what's inside the brackets, so it's going to become 2, okay. Now I'm going to actually expand some of these things out. So, well, first of all, actually, I'm going to take a ce to the t out, same thing as I did before, ce to the t out, okay, both of these things. Okay, and let's see if I can combine things together. So I've got a sine 2t here and a sine 2t here. Okay, and I've got a 2d plus e there. So basically I'm going to write my sine for the moment. Oops, I didn't mean to do that. So I'm just going to bring this. Up with my sine. Okay, so let's bring this up with my sine. Up there. Oops, going to overlap. Okay, that's fine. What I'm going to do then is just bring this down here then, just to get it out of the way. So bring the causes together and bring the sines together. Of course, in the exam, you just write this out a load of times. Or if you're doing it yourself, just write it out loads of times. But obviously, because I've got a pen, I can erase things. I can kind of do it more visually, I think. Okay, so now I'm just going to take out a sine 2t of these two things. Take a sine 2t out of these two things. And I'm going to try and make a bit of simplification in the middle here. So I've got this minus 2 lots of that. So d minus 2e, that's fine, d minus 2e minus 2 lots of that thing. So I'm going to say minus 4 lots of d, okay, minus 2 lots of e. Okay, so what am I left with? I'm left with d minus 4d is going to be minus 3d, and then minus 2e minus 2e is going to become minus 4e. Okay, so that's my first thing. Now let's try and do the same for my cos. So I'm going to take out, this is a plus in here, so I'm going to take out cos 2t of those two things, expand that thing out, so it's going to become 2d minus 4e, okay, and then these two things just going to be added onto that, so it's 2d plus 2d, that's going to become 4d, and then we've got minus 4e plus e, that's going to become minus 3e, so what am I left with? Let's just try and tidy this up. So there we go, that's it written out, that's what I'm left with, okay. But I'm actually going to make a little bit more of a substitution. I'm going to basically multiply everything through by ce to the t, okay. Or more specifically, I'm going to write it, I'm going to multiply it through by c. Okay, I'm going to leave the e to the t out the front. So if I multiply this by c, I end up with c times d and c times e in here, okay. If I multiply this by c, I end up with c in here and a c in here, okay. So I'm just going to write this as c times e. Okay, and likewise I end up with a c in here, and a c in here. Okay, let's do the same down here. So I end up with a c times d and a c times e. Okay, and I end up with a c times d and a c times e. and a c times e. Okay, so basically if I say, well look, c times d is just going to be some constant. Let's just call it a, because of course two numbers being multiplied together will just equal a third number, so that's just going to be a, let's just call it. Okay, and likewise c times e, same principle, two numbers being multiplied together, just going to equal another number, so let's just call that b. Okay, so now if I replace, whenever I see a c times d, if I replace that with an a, and a c times e, I'm going to replace that with a b. C times d, I'm going to replace it with an a, so an a plus 2 lots of b plus 2a. Okay, replace that with a b, and this is going to replace with an a. This I'm going to replace with a b. Okay, this I'm going to replace with an a, and this I'm going to replace with a b. The reason why I've done that is that now instead of having to find, c, d, and e, so instead of having to find 3 things, I only have to find now 2 things, just a and b. Okay, so now the idea is then, it's a lot of algebra, but it's actually really straightforward. It's exactly the same as we did before. This is why I didn't really consider. By the way, I'll just try and show you. If this right-hand side actually looks something like, let me just write it down here in a new piece. If this right-hand side looks something like with a polynomial in, remember we include polynomials as being, we include polynomials as being anything above the power of 1. Okay, so let's say, for example, if it was minus 8t e to the 3t, I don't know, let's get rid of that, so 8t, say, e to the 3t cos t, okay, then what is the solution you would try? Well, that's a polynomial, okay, that is an exponential, and that's a cos, okay, so therefore what would you try? You'd try, the solution for the, if it was just a polynomial, would be at plus b, okay, the solution if it was just an exponential, would be, let's call it c e to the 3t, okay, and the solution if it was just a cosine was just that, so it's just be d cosine t, okay, so in other words, the solution which we're looking for will be all of those things multiplied together. Then you just see if you can make any kind of simplification in the constants, so you only have to find less constants, okay, but that's just kind of by the side. So basically, just be careful. As soon as you see a t involved, then therefore you have to introduce a polynomial as well. Okay, so if it's t squared, t cubed, whatever. So okay, let's go back to our example up here. So in other words, what we want to do is we want to put all of this back into there. So it's going to be quite a little bit of work, but let's have a look. So let's have a look at this. So I've written it like this. It's all written kind of as one, but I've staggered it like this, and I can just make a bit of a cheat because I've got my special pen. Okay, so let's take this. So I'm just going to replace y double dash with that. I'm going to replace my y dash with this. Y dash with this. Okay. I'm going to replace my y with this. Y with this. Okay. So first thing I'm going to do is I am going to. You can see there's an e to the t there immediately. So an e to the t, e to the t, and e to the t. I'm going to cancel the e to the t's off. Okay, just to make it a little bit easier to work with. Okay, and then basically it's a case of multiplying all of that out and equating coefficients. So let's have a look. I'm going to multiply this all out. I'm not going to. Let's just try and multiply this out. So basically what I end up with is minus 3a sine 2t. Okay, minus 4b sine 2t. Okay, so that's my sine 2t. I'm going to try and keep track of my sines and coses. So that's that one. That's that first one sorted with. Okay. Now my second one, I'm going to do the same for cos. So I end up with 4a cos 2t. Or actually, there's no point even just doing that, is there? I'm just going to write down. Okay, this is the quick way of doing it. If you're in a rush, this is the quick way of doing it. You could kind of expand it all out like I was just about to do, but this is the quick way of doing it. Basically, what you do is you've only got 2 things now. Okay, you've got sine and you've got cos. You've got sine cos, and then the right hand side you've got sine cos, but of course sine coefficient just be 0. Okay, so all you just do is just say, right, for sine t, just underline sine t, and cos t. You just write down. Sorry, that's 2t, isn't it? 2t and 2t, and you just basically compare the coefficients directly. So basically for sine 2t you end up with minus 3a minus 4b, okay, plus so that's that one sorted with, minus 4a minus 3b, 4a minus 3b, okay? And then, sorry, that's for cos, isn't it? Oops. Probably confusing you now. Okay, so that's sine sorted with. So let's find the other one involving sine. There's a sine one there. So remember be careful of the minus 3 being multiplied out the front. So you end up with minus 3 lots of a minus 2b. Okay, and then there's a sign there. So let's say this is, careful, there's a minus 4 there. So it's going to be minus 4a. Okay, and then what's the sine coefficient on the right hand side? So this thing down here, well, it's just going to be 0. Okay, sine coefficient on the right hand side is going to be 0. Let's do exactly the same for cos. Let's do exactly the same for cos. There's a cos there, so this is going to become 4a minus 3b. 4a minus 3b. Okay, there's a cos there, so be careful of the minus 3 out the front. So it's going to be minus 3 lots of 2a plus b. 2a plus b. Okay, so that's that one sorted with. Then be careful of the minus 4 there, because I've got cos there, so it's minus 4b, and that's going to be equal to, what's it equal to? It's minus 8. Okay, because that's the cos coefficient there. So therefore, we've got everything sorted with. Now. So now it's just a case of
so in this video, we're going to...
Sorry about that. So now it's just a case of expanding these two things out to find out what a and b is equal to. So let's do a little bit of simplification. Let's first of all get rid of this bracket here. So minus 3a, and this is going to become plus 6b. Okay. Likewise, it's going to become minus 6a, and it's going to become minus 3b. Okay. Let's just do a little bit of simplification now. So we've got minus 3a, so it's going to become minus 6a. Okay, minus 4a, so it's going to become minus 6 minus 4, it's going to become minus 10a, so minus 10a. Okay, and then we've got minus 4b plus 6b, that's going to become plus 2b. Okay, plus 2b equals 0, so that's my first equation, which we've got to solve. Okay, and then let's do the same for down here, so I end up with 4a minus 6a, so 4a minus 6a is going to become minus 2a. Okay, and then we've got minus 3b, minus 6b, minus 4b, it's going to become minus 10b. So minus 10b, and that's going to be equal to minus 8. Okay? So let's have a look at this. So let's just try and solve what b is equal to. So 2b will be equal to plus 10a. So I've just rearranged that. Okay? So therefore that implies that b must be equal to 5a. B must be equal to 5a. Now let's just replace b with 5a in here. So I end up with minus 2 minus 10 lots of 5a. So it's going to become minus 50 lots of a equals minus 8. Do a little bit of rearranging. Minus 2 minus 50 is going to become minus 52a. Okay, divide through by minus 52. That's going to be equal to... The minuses are going to cancel. It's going to be 8 over 52. Can we divide through by 4? Yes, we can. It's going to become 2 over 13. 2 over 13, I think. Yep. And so now I'm going to use that. I'm going to use that in here. That b is just going to be equal to 5a. So b is going to be equal to 5a. So a is just going to be 2/13. So just replace this with 2/13. Multiply the two together, it's going to become 10/13. So there are my two coefficients. I've got a is equal to 2/13. B is equal to 10/13. Well, what was the original thing that I was trying to try? What was the original thing I was trying to try? I've got rid of it, haven't I? It was, I'll just write it out again, minus, it was e to the 3t, and then a sine 2t, plus b cos 2t. That was the original thing that I was trying to try. Okay, you can rewind the video if you wanted to and find that, but that was the original thing that I was trying to try. And I've just worked out that a is equal to, what was a equal to? A was equal to 2/13, b was equal to 10/13. So a was equal to 2/13, a was equal to 2/13, and b was equal to 10/13. B was equal to 10/13. Just replace the two things together in there, so I end up with 2/13 there, and I end up with 10/13 in there. Okay, so that is now a particular solution that satisfies this. So I found a particular solution to that. So same thing, you know, my general solution must be my complementary solution, which if you remember is C1 e to the 4t plus C2 e to the minus t, that's the thing there, plus my particular solution, which is all of that thing there. So all of that thing there is just going to be, let's see if I can do this. Oops, just going to knock it off the screen. Okay, let's make it a little bit smaller. There we go. So that is my general solution that will satisfy that equation. That is my general solution that satisfies this equation. So basically, the thing which I wanted to show you, it's kind of, the more terms you have, the more kind of algebra it is, but it's just algebra. the same ideas kind of retain. You know, it's the same ideas, completely the same ideas. Okay, the idea is then you just build the solution. So you look at your right-hand side and think, right, what have I got? And if you're just multiplying them together, then you just, you know, are multiplying an exponential by a cosine or a polynomial, whatever. And you just multiply the general solutions which we found in the previous videos for each one of those cases. Okay, and then just try and make simplifications if you can for the constants. You don't have to make the simplification for the constants. You just find it's going to be a hell of a lot easier if you do, because otherwise you'll have loads of things to solve. But yeah, you know, you just do that, and you know that's basically how you do it. Just if you've got products of things being multiplied together, then therefore you can just use this method and just build the solution from what you know.